Hello, we are Team 1110. I am Weston Murdock.
And I am Isaac Lynn.
I am Julius King, and we worked on problem C. Now we go over the background of the project. So, on a real world basis, refugee settlements in Uganda were formed as a result of conflict in Sudan. Each settlement has a different method for resolving disputes among refugees, but the diverse cultures of the refugees can affect these approaches to conflict resolution. So, for our problem, there were three different types of conflict resolution: negotiation type A, arbitration type B, and mediation type C. So our problem is investigating how we model that interaction of these ideas over time and what happens in settlements with multiple ideas. So how do negotiators and arbitrators interact? Well, each group uses a single model of conflict resolution, and we'll see the other's method as a very different idea. With a large enough difference in population, one group may be pressured to defect to prevent conflict. So if A is much larger than B, then B will convert. With similar populations, the two ideologies may reach a compromise, so they'll discuss to reach an agreement over time. So how do the mediators interact? Well, the mediators have a mixed model of conflict resolution. They can be variable and fit and flex to fit the populations involved, but they can also be considered mature since it's both empathetic to individuals and communities. They're sympathetic to both previous ideologies and less likely to be adversarial. So how do all the groups together interact? Well, interactions between different groups can result in convincing one party to convert to the other due to possible peer pressure, creating an intermediate compromise idea in which the groups talk and try to reach an agreement as time progresses. And it's more likely that adversaries will compromise than convert. So A and B, given their different models, will talk more rather than just convert to each other. So now we work on developing a model. Well, what should our model do? It's going to predict general trends over time. And then we assume that group dynamics function proportionally to group size, so that the change in each group depends on the size of each group. And we allow for different realistic scenarios depending on different initial populations and made it so that it agrees with the real world case. So we assumed that mediation would grow more than the other two groups, and we also assumed that compromise was more likely as time progresses, which means that the groups will discuss more as time progresses. We also assumed that it was unlikely for people to convert between A and B directly, as well as that the population P, or the sum of all of the groups, is constant, and that the influence of resolution types is symmetric, so they all influence each other to the same proportions. So when we started developing the model, we started with Hardy-Weinberg models, and we made it so that we accounted for the theorized compromise between each group, and we normalized the populations to a total population P. And we also made it so that the compromise likelihood is low at the initial time and increases as time progresses after quote-unquote discussion between the populations, and that the sum of all ratios stays 1.0.
When you take these factors into account, this is the resulting model. We note that each derivative has three components, two of which as conversion factors to convert one group to the other, and one of which as a compromise factor. We note that the sum of the compromise factors is 0, and the sum of the conversion factors is 0. The conversion factors are direct representations of proportionality. Because the alpha factor is present in populations A and B, it will be directly related to both populations A and B. It's also directly related to the difference between populations A and B. If population A is higher, it'll be positive for population A and negative for population B. We note that all 6 of the conversion factors are symmetric and follow the same rules. We know from our assumptions that compromise will have a time dependence. We also know that compromise will depend on both populations A and B. Then additionally, the compromise will be proportional to A as it relates to A, proportional to B as it relates to B, and proportional to A plus B as it relates to C in order for it to be symmetric, because it's subtracting from A and subtracting from B and adding to C over time. The units for our constants are listed below, where time is measured in years. Now we'll discuss the implementation of our model. We chose to use a numerical Runge-Kutta 4 method to visualize our model. For this visualization, we kept our constants consistent, and these constants are listed below. This first graph shows the results of our model with no compromise. The initial populations are negotiators and mediators, and so they have no need to compromise to another group, just simply to converge to the other. It's worth noting that after this particular graph, no other graphs will be used with the high initial population of mediators, because as per our model, there's no way to decrease the mediator population without it already being a low population, and the model is set up, so to speak, such that mediation will be favored if it's already high, because we assume that negotiators and arbitrators would be more likely to convert to mediators than to form a conflict between the groups. In this model, we see sigmoidal increase in mediators from 56% up to 100% after approximately 140 years. These next two models show compromise between groups that initially have no mediators. So in these groups, we just have negotiators and arbitrators initially. And while there's conversion between the groups, there's also conversion to mediators, which in the first case results in a high enough concentration of mediators so that the mediators, quote unquote, take over. Whereas in the second scenario, the initial population of arbitrators is not high enough, and the mediator population does not get high enough to overtake the negotiators. In this final set of diagrams, we see 3 initial populations instead of 2 initial populations, and we see similar behavior to that of the spontaneous compromise. Sigmoidal increase of the highest group or of the mediation group if the initial populations of negotiators and arbitrators is close enough to each other.
And now on to the results and conclusions. As a brief interpretation of our results, notice that most of the curves resemble a sigmoid in their shape. This is very similar to what you might expect to when you would introduce a group of skeptics to a new idea and they warm up to it over time. On this slide, we can see the importance of choosing realistic constants. On both of the graphs on this slide, we can see that the initial populations for the 3 groups are chosen to be the same, but the constants modeling their behavior are chosen to be slightly different. This causes dramatic changes to their short-term and long-term behavior. As such, it is extremely important to make sure that your constants are chosen correctly, as the long-term and short-term behavior of the system can change dramatically based on these constants. Additionally, as a way to modify our model, we have also introduced the idea of a resilient population. In essence, a resilient population is a subgroup of each group in the population that is stubborn and chooses to continue to practice their ideology even if the majority of people in the population choose not to. On this slide, we can see what happens when we change our differential equation in order to adapt to this resilience model. In essence, this replaces the A, B's, and C that we know before as A, R, B, R, and C, R, where A, B, and C are defined as before, and R, A, R, B, and R, C are constants chosen between 0 and 1, reflecting the proportion of A, B, and C that is resilient. On this slide, we can see what happens when we implement this model. In the graph on the left, we choose the negotiation population and the arbitration population to have some proportion that is resilient. This is only seen in the arbitration population as it stabilizes at 0.2, as expected from having chosen RB to also equal 0.2, despite what the long-term behavior of the negotiators do. In the graph on the right, we chose a portion of A, B, and C to be resilient, and you can see that the proportion of both the negotiators and arbitrators that holds out in the long term is equal to what their resilient populations were chosen to be, whereas the long-term behavior shows that the mediators win out overall. Now, looking at some of the possible shortcomings and improvements of our model based on the results that we've seen so far, note that the model tends to converge to a 1-0-0 ratio in its end behavior, at least without resilient populations. This may or may not reflect reality. Additionally, note that the time dependence of the compromise in each differential equation may or may not reflect how compromise works in reality, and it would be necessary to determine, based on actual data, whether or not this is correct. Additionally, we need to determine reasonable ranges for each of the constants based on real-world data. As was shown in the earlier slides, it is extremely important to choose your constants carefully, and thus a large amount of data will be necessary in order to determine what the actual ranges for these constants should be chosen from. Furthermore, we can see that mediators tend to dominate over the other populations in the majority of our models. This may or may not actually be correct, and it's necessary to check real-world actual data in order to determine if this is correct or not. In conclusion, our models generally favor a peer pressure approach to the spread of the ideas. This generally causes populations to conform to one main resolution method. Again, we can also see that our model predicts that mediation will become the most widespread method of conflict resolution, although, as mentioned earlier, mediation may vary from population to population, and thus from settlement to settlement, the actual implementation of this mediation may vary significantly. As a whole, human behavior is also extremely unpredictable, and so by monitoring a settlement over time and choosing constants extremely carefully using large amounts of data,